Hey there, I wanted to record a few review problems that have shown up on your WebAssign chapter review. These are just some emails that I have gotten from some of you asking how do you solve this or asking for help in the Ask Your Teacher section of the review. So I just wanted to kind of compile the ones that I have gotten the most and do a little bit of review. So I'll do a few, this is the first video, I'll do about 5 short ones so that if you don't want to watch the whole thing, then you can just go to the ones that you're struggling with. So this video, we're going to solve these two problems, finding solutions of different equations. So we're going to start with the first one, x to the fourth minus 6x squared plus 9. So how do we solve this? We're going to try factoring, but always, right, this is not a linear equation. The degree is higher than 1. So the first thing is set equal to 0. So when you set it equal to 0, that means we're going to subtract 4 from both sides. And so when we do that, what do we get? We're going to have x to the fourth minus 6x squared plus 5 equals 0. And now I can try to work with this. And the reason I said factor is because I recognize that this is a quadratic. How do I recognize this is a quadratic? The degrees differ by 2, right? So if I square x squared, I get x to the fourth. So that lets me know that I have a quadratic, right? So if I have x squared minus 6x plus 5, this has a quadratic form, but I could also have x to the 6 minus 6x cubed plus 5 equals 0, right? If I take x cubed and you square it, you're going to get x to the 6. And so that's what lets me know that I can treat it like a quadratic. If the highest power is essentially the square of the middle term, of the middle x, then it's a quadratic and I can treat it as such. So let me get rid of that so that we don't get too confused. And going back to this one. So I can treat it like a quadratic. So then I'm going to ask myself, I need two numbers whose product is 5, positive 5, and whose sum is negative 6. So what numbers give me a positive product? Well, they have to be either both positive or both negative. But in order to get a negative sum, then they both have to be negative. And so negative 1 and negative 5 work. Negative 1 times negative 5 is positive 5. Negative 1 minus 5 is negative 6. And so I'm going to use those in here. So I'm going to have x squared and x squared, right? Because x squared times x squared is x to the fourth. And then the two numbers I found, minus 1 and minus 5. And can I keep going? Yes, these are still quadratic, so I can continue factoring. This is a difference of two squares, so it's x plus 1, x minus 1. And you can try to factor that one with a radical, but that may seem confusing right now, so I'm just going to leave it as it is. And we're going to use the zero product property here. So either x plus 1 is 0, or x minus 1 is 0, or x squared minus 5 is 0. This one tells me x is negative 1. This one says x is 1. What about this one? We can move the 5 over. So I'm going to have x squared equals 5. And now we can take the square root of both sides. Now, I am taking the square root of a variable. So remember, anytime you take the square root of a variable, we gain a plus or minus. So this becomes x equals plus or minus the square root of 5. So what are our final answers? We can say negative 1, 1, negative root 5, and root 5. I know we always say write things from smallest to largest. If you want to write them in order, you can write the smallest one first. So which one is the smallest? Negative 1 or negative root 5? Well, negative square root of 4 will be negative 2, right? So then negative root 5 is the smallest, then negative 1, then 1, then the square root of 5. Again, my point of reference is kind of the square root of 4. The square root of 4 is 2, so that means the square root of 5 is larger. And so that's how we solve this one. When I said you could factor the x squared minus 5, it's not a perfect square, but you can say this is x minus root 5 and x plus the square root of 5. So that will be another way you could have done it. But whenever it's not a perfect square, you can still set it equal to 0 and then do the square root property. All right, so let's try the second problem, the absolute value. So we want to solve the absolute value of 4, absolute value of x minus 5, minus 3 equals 7. So let's solve that equation. Okay, so with absolute value equations, the big thing we're going to think about is we want to isolate the absolute value on one side. So I always think of absolute values as brick walls. You can't bring anything in, so I don't want to distribute the 4 in, and you can't take anything out. You can't take this minus 5, so I can't say plus 5 with the absolute value still there. So that's why I think of them as brick walls, right? You can't bring anything in, you can't take anything out until the absolute value is by itself on one side. So we're going to try to get it by itself. So add 3 to both sides. And so this becomes 4. Absolute value of x minus 5 equals 10. I don't have it by itself yet. I have that 4 there. And remember, brick walls, so I can't bring this 4 in. So that means we have to divide both sides by 4. And I know we're going to get a fraction, but it's okay. Fractions are friends, not food. Sorry, I watched Nemo lately, can you tell? So then this is the fraction that we get. And now absolute value equations, right, they've given us the distance. This represents the distance between x and 5 is 5 halves. So we want to find what value of x gives us a distance of 5 halves. And back in this section of chapter 1 when we did absolute value, so I want you to think of the number line. So this says the distance between x and 5 is 2.5, right? If you change 5 halves to a decimal. So we want to know where is x. Well, we could move to the right 5 halves, right? The distance of 5 halves. So that would be saying x minus 5 is 5 halves. Or we can move to the left. So we can go 5 halves to the left. So how do we indicate 5 halves to the left? We say, or we can have the difference between x and 5 is negative 5 halves. So this negative just indicates that we're going in the left direction. And so for absolute value equations, you're always going to have two answers. And if it was an absolute value inequality, you're going to have two ways also. You can go to the right or you can go to the left. Going to the right just means you drop the absolute value. The number, in this case our 5 halves, stays the same. Going to the left means you drop the absolute values, but now that number that's on the other side becomes a negative. All right, so let's solve. So add 5 to both sides. And what do we get? So this becomes just x equals 5 plus 5 halves. Get a common denominator. Common denominator is 2, so multiply top and bottom by 2. So I get x is 10 over 2 plus 5 over 2, which is 15 over 2. I like fractions, so just leave it as a fraction. There's no need to change that to 7.5. Now do the same thing on this one. So add 5 to both sides. So I get x equals negative, let me do the 5 first. 5 minus 5 halves. So same thing, get a common denominator, which we already did in the first part. So this is 10 over 2 minus 5 over 2. So x is negative 5 over 2. Nope, positive 5 over 2. Right? 10 minus 5 is usually positive 5. And so those are our answers. So how do you write your answers? Right, you can box them up like I did here, or you can write it as a solution set. So the answers are 5 halves and 15 halves. Always write the smallest one first, or left to right if you're moving along a number line. And those are our solving equations. So with absolute values, the main thing to remember is that you always have two answers. If it's an equation, and if it's an inequality, you have two inequalities to solve. In the next video that I'm going to do, we're going to do a factoring problem. that has been asked also. So we're going to factor this expression. So if you are struggling with how to factor this, something like this, then watch the next video.